Hello. In this short video I want to introduce the new Lattice Topology Optimization tool in ANSYS Workbench version 19.2. We've had Topology Optimization for a few releases now, but this is a new feature for producing an optimized internal lattice for solid geometry. So this is specifically for 3D printing applications, as it produces a design that is really only possible to manufacture via 3D printing. So this is my static structural analysis that I'm starting out with. I have a simple block, I have a fixed support at one end, and a force at the other end. And that produces a deformation. Now this feeds into the Topology Optimization tool. So this is the optimization region. So I select the block, and I choose a lattice type, and a minimum density and a maximum density, and a lattice cell size. And so you can see what sort of lattice types we have available from this drop down. I will open up the ANSYS Workbench help, and you can see them here. So these are the 7 different types of lattices that we can apply to our solid geometry. I'm going to choose the diagonal type. So I've chosen my lattice. I set an objective, so I'm going to minimize the compliance, and then there's a response constraint. So I'm going to retain 60% of the mass of this part. So we run the optimization. It produces a lattice density plot like this. But we want to see what the actual optimized lattice looks like. So we need to feed this result into SpaceClaim, and SpaceClaim will take the geometry and apply the lattice optimization and create the geometry. So if we go back to Workbench, we can see this result feeds into SpaceClaim. So I can double click on SpaceClaim. Now this is our original geometry. So I go to the Facets menu and the Shell feature, and then I select the geometry. And if I choose Type Basic, there's an option here for Use Density Attributes. So I click on this, and this means it's taking the optimized result out of the topology optimization and it's using that as the settings for the lattice optimization. And this will be a variable lattice, so it will have a different density depending on the location inside the block. So I choose these settings, and then I click the tick button, and it will apply the lattice optimization. So in order to see what this looks like, I have a pre-prepared one because this takes a few minutes to run. And I've sliced it open, and you can see inside now that we have the variable density lattice. So if I zoom in, you can see in some areas we have much thicker members in the lattice. In other areas we have much thinner members. Now I could change the minimum lattice density to something larger than 0, so we get a more realistic result. As you can see, we have some excessively thin members here. And these are the thicker regions, and so forth. And this is the closed part. So then you can go and take this and feed it into a 3D printer and manufacture this part. So thank you for watching.